All right, so for the third exit ticket, we're going to go over 11 through 15. So 11 is still on our dinosaur passage. So this says both scientist 1 and scientist 2. Now the key term here, if it says both, that means that you look at the passage first. Would agree that the skeletons of theropods were an important contributing factor to the evolution of flight, maybe. Not an important contributing factor to the evolution of flight. Brittle and light, dense and heavy. So, let's see. Modern birds arose. Scientists believe the evolution of flight was the key to their survival. The manner in which flight evolved remains unsolved. So, this time the passage actually didn't give us the answer. So now let's look at the skeletons here. Fossil records show that the theropods, the oldest known ancestor, had large curved claws suited for perching on tree branches. So yeah, that would be important for scientist 1. Now let's see. Fossils and skeletons of living birds show that rather than evolving flight from tree tops, Archaeopteryx and its relatives used their wings to produce thrust while running on the ground. The propulsion generated by the theropod's muscular hind legs allowed them to achieve sufficient speed to become airborne. So, it's important for scientists 2 as well. Now, here we actually can use our strategy question because these aren't direct contradictions. These two are almost identical, so I didn't even look at C and D. I only looked at A and B to find the answer was A. All right, number 12. Both scientist 1 and scientist 2 would agree that. So we need them to be consistent. The existence of wings preceded the development of true flight. Long tail feathers on theropods impeded running. That contradicts one scientist. Curved claws were ill-suited for everything except perching. That also contradicts one scientist. Curved claws were used to attract prey. We never see the word prey, so I can cross off D. So that means the answer for 12 is A. All right, now let's go to this passage, which we have not seen before. 13. According to both scientists, the net-like structures are found. So it says both scientists. I'm going to go to passage first. The cell. In 1898, an Italian scientist made an illustration of a nerve cell which he had observed through a microscope. Staining procedure darkened certain features. As part of the procedure, nerve was immersed in a solution called potassium dichromate and then immersed in silver nitrate. Due to uncertainties, the interpretation of the net-like structures seen in the illustration remained unclear for several decades. 2 scientists debated possible explanations for the appearances of these structures. All right, scientist 1. Let's see. Surrounding nerve cells, within nerve cells, on the surface, and within the protoplasm. So, this one says the net-like structures are not a true feature of the cell, but an artifact of the staining process. And this is a specialized subunit of the cell. It's in the protoplasm, but it's in the cell. And this one only stains a small percentage of cells. Any features using this procedure could be failures of some of the similar ions. The procedure does not allow living cells. So, I'm going through right now in this video. You can hear me skimming in this question to try and figure out the answer here. Within the protoplasm of dividing cells, that's not going to be the answer because that's very specific to scientist 1. And surrounding nerve cells, potentially. So let's look at the difference in the answer choices here. So for number 13, what we see is scientist 1 thinks that this is an internal feature, and scientist 2 thinks that it only happens on some cells. But if you see it, that means it's in the nerve cell. So scientist 1, regardless, says it's inside. Now scientist 2 says it is not a true feature of the cell, but it stains on the cell. Both of those things are going to be within nerve cells in general. All right, number 14. Which of the following hypotheses about net-like structures would be supported by both scientists? They play a central role in cellular nutrition. They are probably not a new organelle. We know that's wrong because scientist 1 says it's a new organelle. They are too small to be observed through a microscope, and they may be related to cellular processes. So, the structures may also be related to cellular division, and this one is it may play a role in cellular nutrition or secretion. So these two things that they said are different processes, but they're still processes. So that means the answer to 14 is going to be D. So they said different things specifically, but in general, that means that it's going to be related to something in the cell. Which of the following conclusions would both scientist A and scientist B agree with when explaining the staining process? Uncertainty in the process can lead to a variety of interpretations. Scientist B definitely says that. The process is effective for revealing cellular organelles. Let's see. Other staining. The appearance and location of the IRE change according to the level of activity, suggesting it's true, although it is too early to definitively state. So that phrase right there lets me know that you can't say something all the time. So scientist B says that too, or scientist A. So let's check this. The process is effective for revealing cellular organelles. No, because scientist B thinks it's an error. Potassium dichromate works better than silver nitrate for visualizing parts of the cell. They don't always talk about that, so that's going to be a no. And the last answer choice got cut off on my paper, but it says the staining process is random, but can reveal portions of the IRE. So that's only scientist 2 right there, so it can't be that one. So the answer has to be A.